Good afternoon, all. A very hearty and warm welcome to every group present in the meeting right now. This is Harshit, the group leader of Group 6, here to present another fascinating and amazing presentation made by the students of Group 6. Today, we are going to discuss on the topic golden ratio. It is a very fascinating topic, and you will get to know a lot about this topic. So, without wasting any more time, let's get straight into the presentation. Now, before going deep into the topic, let's first understand what basically golden ratio is. Golden ratio. Golden ratio is the ratio of a line segment cut into two pieces of different lengths such that the ratio of the whole segment to that of the longer segment is equal to the ratio of the longer segment to the ratio of shorter segments. In simple words, the golden ratio is a number often encountered when taking the ratios of distances into simple geometric figures such as the pentagon, pentagram, decagon, and dodecahedron, and it is represented in the symbolic form of phi. The origin of golden ratio can be tracked back to Euclid, who mentioned its extreme and mean ratio in the elements. So now we know that what is golden ratio.
Deriving the golden ratio. A straight line is said to have been cut in extreme and mean ratio when, as the whole line is to the greater segment, so is the greater to the lesser. Two distances are said to be at the golden ratio if the ratio of their sum to the greater distance is equal to the ratio of the greater to the lesser. There are countless rich examples of how this ratio describes the proportions of things in nature and how it was used by many artists and architects to create aesthetically pleasing works.
We can derive the actual value by considering a line segment whose parts obey the golden ratio. By starting with the mean and extreme ratios, we can solve for A using quadratic formula and then solve for ratio of A to B. B multiplied by A plus B equals to A square minus AB minus B square equals to 0, minus B plus minus root minus B square minus 4 multiplied by 1 multiplied by minus B square upon 2 multiplied by 1 equals to A. We can reject the negative value since we are working with the measurements and the ratio between positive numbers has to be positive, but since 0.618 is the reciprocal of 1.618, it still plays an interesting role.
A final interesting piece is that if you start with a golden rectangle, you can divide it into a square and a smaller golden rectangle, and then again into a smaller square and an even smaller golden rectangle, etc. And if you keep going, what you find is that proportions of each new golden rectangle follow the Fibonacci sequence. Fn is equal to Fn minus 1 plus Fn minus 2, 0, 1, 1, and so on. It turns out that the ratio of two consecutive numbers in the Fibonacci sequence approaches the golden ratio as a number in the sequence approaches infinity.
Other names of golden ratio and about phi. The golden ratio is sometimes called as the golden section, golden mean, golden number, divide proportion, divide section, and golden proportion. Phi is a Greek letter which is used to represent golden ratio and is equal to the value 1.6180.
Formula. You can find the golden ratio when you divide a line into two parts, a longer part and a shorter part. And when the longer part A is divided by the smaller part B, the sum is equal to the longer part plus smaller part divided by the longest part. In equation, it comes out as A plus B divided by A equals to A divided by B. And this formula helps you in creating shapes, logos, layouts, and much more. Uses of golden ratio in real life. The golden ratio is a great example of mathematics that we encounter almost daily without even knowing it. This ideal ratio is used by many because of its apparent lure of the human eye. The golden ratio has been said to be the most appealing ratio and is therefore used frequently. Everything from commercial advertising companies to painters to even doctors incorporate this magical ratio into their work.
Uses of golden ratio in design. The golden ratio is a mathematical ratio. It is commonly found in nature, and when used in a design, it fosters organic and natural looking compositions that are aesthetically pleasing to the eye. The golden ratio is sometimes called the divine proportion because of its frequency in the natural world. The number of petals on a flower, for instance, will after be a Fibonacci number.
Deriving the golden ratio. A straight line is said to have been cut in extreme and mean ratio when, as the whole line is to the greater segment, so is the greater to the lesser. Two distances are said to be at the golden ratio if the ratio of their sum to the greater distance is equal to the ratio of the greater to the lesser. There are countless rich examples of how this ratio describes the proportions of things in nature and how it was used by many artists and architects to create aesthetically pleasing works.
Pentagram. No, not with chart. The pentagram is more famous as a magical or holy symbol, and it has a golden ratio in it. A upon B is equals to 1.618 and so on. B upon C is equals to 1.618 and so on. C upon D is equals to 1.618 and so on.
The Fibonacci number, a series of numbers in which each number is the sum of the two preceding numbers. The simplest is series 1. The golden ratio describes predictable patterns on everything from atoms to huge stars in the sky. The ratio derived from something called the Fibonacci sequence, named after Italian founder Leonardo Fibonacci. Nature uses its ratio to maintain the balance, and the financial markets seem to do as well.
So, here we all come to an end to the topic golden ratio. I hope you enjoyed the presentation. The presentation you just saw contains the heartily efforts by 6 students in all. The name of the students are as follows: Harshit, Govind, Arjun, Aripit, Pushkar and Arya. I hope you understand the golden ratio topic in detail. Thank you all for being so patient again.